Alright, in this video we're going to go over number 4 from the Chapter 2 practice test. So we have Mr. Eicher updating the password policy. And currently it's 4 characters, choosing from each of these options without repetition. So as I think through that, okay, how many are possible? Well, I've got 4 slots to fill. How many ways can I fill that first slot? Well, I can choose any of the 26 letters, any of the 10 digits, and any of these 8 characters. If I count or add that up, that is 44 different characters I can choose from. So I have 44 different options for the first character, and then because it's no repetition, then only 43, 42, 41. I don't need to divide this out because order is important. The password 1, 2, 3, 4, while not very strong, is different than the password 4, 3, 2, 1. So order does in fact matter here, and so if I actually just multiply those things out, I will get 3,258,024. Okay. Part B says, well, what if we just said people can repeat? Well, same logic. How many options for the first choice? But now I could repeat. So I again have 44 options. Same 44 options, because if I wanted to, I could, under this configuration, make my password be AAAA. And if we allow that, it should, of course, be more. One, you can see the math. You're multiplying bigger numbers together, but you're allowing more possibilities. So this time, it's not a crazy amount more, but it is definitely more. 3,748,096. Part C, now we're going to give some more specific rules. As we know, there's, often we see this, okay, you have to have 1 or 2 of each of these types of characters, something like this. So let's say that we're going to say 1 character has to be a letter, 2 numbers, and then 1 symbol. So I'm still choosing 4 things. Now, how many options do I have for that first thing that I choose? Well, let's say that I'm going to choose my letter first. So I've got 26 options. Then I'm going to choose my numbers. Well, there's 10 options. Again, though it's without repetition, so now my second number, I only have 9 options. And then my special character, and there are 8 of those. So once again, I just multiply these things together, and I get 18,720. Now I have to think about, though, the whole order mattering or not, or not here. In the previous problem, talking about the college admissions, it didn't matter which order I wrote the students' names down in. It was the same 5 students. In part A and B, it does in fact matter whether you have 1, 2, 3, 4 or you have 4, 3, 2, 1. Those are different. Now here we have something a little bit sneakier. The way I've written it here implies that I'm choosing letter, number, special character. But that doesn't have to be the case. We could do letter, special character, number, or number, character, letter. So what I have to do here is not divide out the number of ways that I could rearrange these things, but I actually need to multiply again by how many ways I could rearrange these things. Now, this is a little bit different than some of the other examples that we've done because we had said, like we did the Mr. Moen getting dressed example, and he's got to choose his pants and his shirt. Well, it doesn't matter if he chooses his pants first and his shirt second, he's still doing the same thing. But in this case, I'm no longer doing the same thing. It makes a difference whether I choose the letter or the numbers first. So I actually then need to take this answer and multiply it by 4 factorial. And we need to do that because, again, 4 factorial is going to be the number of ways I can take these 4 things and scramble them into some different order. Because, again, how I've written it implies letter, number, character. And it doesn't say that it has to be that way. So we need to take our answer and multiply it again by 4 factorial. Kind of funky. All right. Thanks.